Hi mathematicians! So now we're going to talk about techniques for computing limits. In 2.2 we talked about finding limits graphically. And so now we are going to find limits algebraically, if that's how you spell algebraic. Okay, so if the function f of x that you are looking at is linear. What does it mean to be linear? Right? It's in some kind of mx plus b form. If it's a polynomial, what does it mean to be a polynomial? That means that you have like ax squares plus bx's plus c's, right? Or rational. What does it mean to be rational? It means you have some kind of function in the top, x plus d, and then on the bottom you have some other function, x squared minus 2, where x squared does not equal 2. Why do I have this? Why did I write this over here, where x squared doesn't equal 2? Why does that matter? Right, we want to make sure that this isn't 0. Okay? Just put this in generic terms. Let's make this an f. X squared minus f. You know, x squared doesn't equal to f. Okay. So if you have any one of these kind of normal-ish, unscary, regular, boring kind of functions, go ahead and plug in a. Okay, so you have your limit as x goes to a of your f of x, and it's for all of these kind of boring-ish things, it's really just going to be f of a. Okay, so let's do an example. I don't like those examples. Let's do an example real quick. Okay, so number 2 says the limit as x goes to 1 of x to the third plus 3x squared minus 3x plus 1. So what do we do? Okay, so this is normalish, right? It's just a polynomial. There's nothing frightening going on here. So we are just going to go ahead and plug this 1 value in for all these x's, and so we're going to get 1 to the third plus 3 times 1 squared minus 3 times 1 plus 1, 1 plus 3 minus 3 plus 1, we get 2. Okay, so the limit of this function as x approaches 1 is 2. Again, all we're going to do is plug in this value of a for these. Okay? Anytime it's just kind of normalish, that's what we're going to try to do. And so let's go ahead and talk about some rules that you can use to calculate limits. So these are going to be called the limit laws. So when using these laws, we're going to assume that the limit of x approaches a of f of x, and so this is going to be if you have two functions and you're asked to find the limit, what do? Right? So we have assumed that both of these limits exist for your functions f of x and g of x, And we're going to assume that C is a real number, so we're not talking about imaginary. And n greater than 0 is an integer. Okay, so these are all assumptions that we're working with, and basically these are just assumptions so that we can claim all these things and not worry about anything weird happening, right? So number 1 would be the sum law, and so we're looking at the limit as x goes to a of f of x plus g of x, and so this is just going to be the limit of each of these individually added together. Okay, number 2 is the difference. Feels silly even having to write this down, okay, but if we're looking at the limit of x goes to a of f of x minus g of x, it's going to be the limit as x goes to a of f of x minus the limit as x goes to a of g of x. Okay, so if you're given a subtraction problem, just like the addition problem, you're just subtracting those. Okay. We have the constant multiple law, which basically means that you can pull this constant c out if you want to, and you can put it out front. Right? So instead of dealing with it here, you can deal with it at the end if you so choose. Number 4 is the product, and as you can imagine, just like the other ones, if you are given 2 functions and asked what the limit of them multiplied together is, you can just separate them. It's very boring. None of these laws are very interesting. Okay, but they're important nonetheless, just for us to realize what we can do when calculating these limits. So we have the quotient law. So the limit as x goes to a of f of x over g of x. Again, we're just separating these. Again, just putting in that little caveat, everything's fine as long as this doesn't equal 0. Right? And then 2 more. We have power. So the limit as x goes to a of f of x to the n, we can just go ahead and pull that power out and raise that whole thing to the n, and then the root so we're looking at the limit as x goes to a f of x 1 over n equals, as you can imagine, the limit as x goes to a of f of x 1 over n. Okay? And so these are all our limit laws, and we can use these to go over to find some limits. So let's go ahead and do that. So let's use, I'm just going to go to some homework problems. I don't know what happened with the screen, but my computer just turned off. Hopefully I can just continue. Okay, let's go ahead and do number 7, number 9, and number 13. So number 7, we're looking at the limit as x goes to 1 of 4 times f of x, and we're told to assume the limit as x goes to 1 of f of x equals 8, and the limit of x goes to 1 of g of x equals 3, and the limit as x goes to 1 of h of x equals 2. Okay, and so we're going to calculate a couple things. So here we had the limit as x approaches 1 of 4 times f of x is the same as 4 times the limit as x goes to 1 of f of x equals, I know that this part right here equals 8, so equals 4 times 8 equals 32. Okay, number 9, we have the limit as x goes to 1, f of x minus g of x, and we should write the limit as x goes to 1 of f of x minus the limit of x goes to 1 of g of x equals, we know this value here is 8, we know this value here is 3, equals 5, 8 minus 3. Number 13, we have the limit as x goes to 1 of f of x to the 2/3. And so that is going to equal the limit of f of x as x goes to 1 of 2/3. And so that's going to be 8 to the 2/3. And so what does that mean? People are like, oh no, 8 to the 2/3. What does that mean? You can kind of deal with each one at a time if you want to. You can deal with them both at the same time if you want to. What you can think of this as, right, is this is the same as 8 squared to the 1/3, right? So you multiply these two when it's like that. And so then if I break them apart like that, it allows me to deal with them separately. You can also make that 8 to the 1/3 squared. That's also okay. All right, and so if I look at this, I know that the cubed root of 8 is 2, and 2 squared equals 4. Okay?